Okay, in today's video, I am going to go over how to use the thin lens equation to calculate the image distance, the image height, and the image orientation for convex lenses. And in this case, we're going to have the object distance is greater than f. So we know that if it's greater than f, we have a certain case, and if it's at f, there's a certain case, there is no image, and if it's less than f, it's a different case. And in this case, we're going to use the object distance greater than f. Okay, this is our problem. It says we have an object that's 8.6 centimeters tall. It's 37 centimeters from a convex lens, and the focal length of this lens is 10 centimeters. And we want to know where will the image be, how big the image will be, which is basically its magnification, and what its orientation will be. Will it be inverted or upright? Now, the first thing I think your teachers always tell you, which I think is a good idea, and I think it's a good idea to do this, is to write all the information down. And we know the object, we know the focal length is 10 centimeters. It's a convex lens, so it has a positive focal length. That's important to remember because concave lenses have a negative focal length, but this is a positive focal length because it's a convex lens, so I put down plus 10. The object distance is 37, and the object height is 8.6 centimeters, and we want to find the image distance and the image height. Now, before you begin, I think it's a good idea to kind of think a minute about what the problem is and what our answers should be approximately. And I'm just going to make this sketch. Now, I'm using Keynote to do this, so it looks nice and neat, but what I normally do is I just pick up my pen and pencil, not even a ruler. I just make a quick sketch and fill in the general diagram for a convex lens, which has a principal axis. This vertical line represents my lens. I don't even necessarily draw a lens. And I put F and 2F on both sides as my general sketch. Now, this is not to scale necessarily, but I know that if my object is 37 centimeters away, f is 10, 2f is 20, so 37 is out here. My object is going to be somewhere out here, and like I said, this is not to scale. Okay, now I want to think, okay, where should the image be? What should its orientation be? And what should its size be relative to the object? And that will help me know, or help me think about, when I get my answers, if I feel confident that I have the right answers. Now I know from my ray diagram drawings that if the object is beyond 2f, the image is going to be somewhere here between f and 2f. Now again, this is not to scale. It's not going to be right in the middle, but it's better the object, the image distance from my calculation better be between 10 and 20. It better indicate that the image is smaller, and it better indicate that the image is upside down. And if all that is true, then I have a high degree of confidence in my answer. Okay, so let's go ahead and let's do the calculations. Okay, so once again, here's all the information. We want to find the DI. We're going to do the DI first. We're going to do that with the thin lens equation. The thin lens equation is 1 over f equals 1 over DO plus 1 over DI. And we want to solve for DI, so we're going to switch some things around here. We're going to subtract 1 over DO from both sides. And we get that 1 over DI is equal to 1 over f minus 1 over DO. And again, we're solving for the image distance, which is down here, 1 over DI. Okay, now we can simply plug the numbers in. The focal length is 10, 1 over 10 minus 1 over DO, which is 37, so we get 1 over 37. And I'm just going to put this into my calculator. 1 divided by 10 minus 1 divided by 37. As long as you have a regular graphing calculator, you'll get the right answer. You don't need to use any parentheses or anything like that. If you have order of operations, then you'll come up with that 1 over DI is equal to 0.0730, or 0.073. Now this is probably maybe the hardest thing I think that people have with these problems, is this is 1 over DI. This is not DI. Now we have to take the inverse of both sides, flip this up, we get DI over 1, we get 1 over 0.073, and then we get that DI is equal to 1 divided by 0.073. Okay, all I did was flip both sides up, and I come up with this. And this, again, is not the answer, but if all I got to do now is take 1 divided by 0.073. Okay, on your calculator, you hit 1 divided by and 0.073. All right, and you come up with the image distance is 13.7 centimeters. Now, let's think back for a second. F was 10, 2F was 20. We said the image better be between F and 2F, and then yes, indeed it is. So that makes me feel pretty good about that part of my answer. So I know that most likely I'm pretty good with that, and the answer for the DI is 13.7 centimeters. Okay? All right. Let's go on and calculate the height. Now, in order to calculate the height, we have to get the magnification. The magnification is equal to negative DI over DO. And once again, I'm just going to plug my numbers in. The DI was 13.7, the DO was 37, which was given. I have my negative sign here. Don't lose your negative sign. And I get that the magnification is minus 0.37. Now, what does the minus sign mean? The minus sign means that it's inverted. The 0.37 means that it's going to be smaller. Now we're going to use the other magnification equation, which has the heights in it. We know now that the magnification is HI, the image height divided by the object height. And therefore, the image height, which is what we're trying to solve for, is the magnification times the object height. We plug the numbers in, don't lose the negative sign again. Or once again, don't lose the negative sign, and you get that the image height is minus 3.18 centimeters. Now, there really isn't any such thing as a negative height, but the negative just means that it's inverted from the object. Now, the object was right side up, so this means this is going to be upside down, so to speak. And the magnitude of the size or the height of the object or the size of the object is 3.18 centimeters. Okay, so once again, the negative sign just tells us that it's inverted or the orientation is opposite the object. Okay, so now we can fill that in. We have minus 3.18 centimeters. And if we think about all of that and we go on now and we look at our diagram we had previously, here's our answers. 13.7 is the image distance. Negative 3.0 is the image height. Here where it's the object, we said the image better be between f and 2f, and once again we can see it is between f and 2f, 10 and 20, 13.7 is between f and 2f. The image is smaller, it's 3.8 centimeters tall. This was 8.6, so that's smaller obviously, and this negative sign tells us that the image is inverted. Okay, so if we do all that, follow those steps, kind of go step by step very carefully, then you should come up with the right answer and be successful when you do these problems. Okay, so thank you very much for watching. Hope that was helpful. If you thought that was helpful, you can leave me a thumbs up or a comment in the comment section, and we will see you next time. Thank you.